Hi and welcome. I hope everyone is okay. Now in this lesson, we will go on where state in the state there in the last lesson. As you remember, in the last lesson, we learned um, standard deviation and variance, and now we will learn the different part of the standard deviation and the variance. Okay, now we have a question for exploring the something. 20 adults completed as many laps of a running track as they could manage in 30 minutes. The following table shows how many laps they completed. I want to compute the variance about taking mid values, but uh, I will take mid value, both mid values and different values. For example, in the first column, the mid values is 6. The second column 11 mid values for second column. For third column, mid values is 16. But I want to take the values all different mid values different. For example, I want to take -1 and -1 and -1. And one more thing. For example, plus 0.5 plus 0.5 and plus 0.5. Okay, and I want to compute the variance for these all values, and for one, please remember that variance is equals to the sum of x square over n minus the mean square. So the mean, our mean is the for the mid values 17 and plus 16, 33 over 2, 16.5. And for the second row, the mean is 10, and the other row, the mean is 18 and 38, 18 and 34 point, and it means 70.25. And for the variance, we have group data, so we should use the frequency. So we should use the sum of frequency like these, and the different part, the mean for using the frequency. And the first one, 6 plus 6 multiply 6 multiply 6 36 plus 11 multiply 10 110 plus 16 plus 4 64 over we have 20 values, and we have 20 values. It means 10 10.5. For the other row, 5 multiply 6 30 plus 10 multiply 10 100 plus 15 multiply 4 60 over 20. So it means 10.5. and the other mean 6.5 multiply 6 means 39 plus 115 and plus 66 over 20, and our mean is 10.5, and also our mean the same for all row. And the other section, our variance for the mid values. So you can easily see the same values of variances, and this section, the mid values 6 square multiply 6, so plus, and 11 square multiply 10 plus 16 square multiply 4, and the sum of frequency 20 minus 10.5 square, and it means the approximately that I want to look at my notes for result for using the short time. Our values, our variance value is should be 3.5, 3.5 multiply 3.5 square 12.25, and the other section for the second row, our variance x means 25 square multiply 6, 10 square multiply 10, and 15 square multiply 4 over 20, and minus 10.5 square, and also means 12.25, and the variance x should be 6.5 square multiply 6, and 11.5 square 10, multiply 10, and 16.5 square 4 over like 20, it means 12.25. So this value, if the same value add or minus, it doesn't change the variance or standard deviation. And the other section is calculating from totals. For ungrouped data, we calculate variance and standard deviation from totals and the sum of x and the sum of x square. For group data, we calculate using totals the sum of frequency, the sum of x multiply frequency, and the sum of x square multiply frequency. In both cases, we can rearrange the formula for variance if we wish to evaluate one of the totals. And combined sets of data, the variance and standard deviation of a combined data set are calculated from its totals, which are the sums of the totals of the two sets from which has been made. The worked example, we have an example and given an 25 and the sum of x 275, and variance is 7, and we will find the sum of x square. Please remember that variance formula, our variance formula is in the ungrouped data. For ungrouped data, the sum of the x square over n minus mean square. And please remember that mean is the sum of x over n. So 275 over 25, and it means 11. And the variance value is 7, and the sum of x square over n minus 11 square. So 7 plus 121, and the sum of x square over 25 and 128 means this square sum of x square over 25, and it means the sum of x square is 3200. So the other section is like for worked example. The height x centimeter of 10 boys are summarized by the sum of x 1650, the sum of x square 275,490, and the heights for girls like these values. Calculate to 3 significant figures the standard deviation of the heights for all 25 children. So we should compute the mean for all students. For example, it's called, for example, Z. Z should be the sum of boys' heights plus the sum of girls' heights, and over the number of boys plus the number of girls. So 1650 plus 2370 over, we have 10 boys and 15 girls, and it means I want to result to this section 4020 over 25, and it means we should use the exactly value. Please remember that I write to you not rounded value, so it states here like this. And I want to the variance for the variance value or variance of z like this. The sum of x square plus the sum of y square over number of boys and plus number of girls minus mean square. So and if we want to standard deviation of z should be the square root of variance, and the square root of variance like the 275,490 and plus 377,835 over, we have 25 boys minus mean square 420 over 25 square, and this is approximately like that 16.6. And note, please remember and please notice that the variance of two combined dataset X and Y is general equal equal to the mean of variance, not equal to the mean of variance. We should compute the sum of all values. And if two sets of data denoted by x and y have an x and y values respectively, then the mean and variance of their combined values are found using the totals these values. So the mean of x and y combined here, and the variance of x and y combined, this formula for the x and y combined the formula. In an examination, the percentage marks of the 220 boys are denoted by X, and percentage marks of the 80 girls denoted by Y. And the marks are summarized by the totals, the sum of X and X square, the sum of Y square. Calculate the girls' mean mark given that the standard deviation for all students 10, and our standard deviation, like this, and the sum of x square for 424,320 plus the sum of y square, so 352,130 over the number of boys plus the number of girls minus mean square, our mean, let it be z, so z square, and standard deviation is 10, and I want to result for this situation, these and 3 and 3,882.25 minus z square is 100, and then the z square is the sum of x values plus the sum of y values over the number of x plus the number of y, and it means that the sum of x values 720, the sum of y values I don't know, so 720 plus the sum of y values over the number of students 200, these, and the z square, it means this square. And if I put the instead of the z values, like the sum, I can find the sum of y is 5,208, and the girls mark y means the sum of y over the number of girls, so the y means 5,280 over we have 80 girls, so this 80, and I want to compute the marks of girls, so 5280 over 80, like 66, and the 66 point is the marks of girls. Okay. Now we can access the result, and for now our lesson finish, and have a good lesson and have a good day.